Okay guys, let's begin this tutorial. We start creating a public class, and in the inside we're gonna declare some data, public int data, as well as a reference to the next node in the list, public node next. After that we're going to create a constructor. This constructor takes a parameter that we will call I. We copy that information into data and set the next node to null. Now we can actually go ahead and start playing with this node. So I can drop down here into main. Let's create a node. So I can say node, my node is a new node. And then we will pass an arbitrary number here, just like 7. Now the question is how to start adding more nodes to this list. Well, one approach would be to say my node next is a new node. Then again passing an arbitrary number here, just like 5. We could actually continue this pattern and say my node next next is a new node. In this case I will pass 11. We can do this any number of times. We can do my node.next equal new node and passing 4. Let's check if it actually runs. We need a way to visualize this. So let's go back to node here. We're going to put a print method. We can say public void print. If we tell a node to print, we can make it look like a linked list. So let's say console.write. So first a bar symbol, then we will print the data, then we will print another bar, and later we will add an arrow pointing right. Then come back down here and we'll tell my node to print. If we went ahead and run it, you can see that 7 appears. But the question is, where is the 5, the 11 and the 4? The trick here is going to use recursive method. After I tell this node to print itself, what we can say if the next node doesn't equal null, let's say next node dot print. The reason that works is that this next is actually a node. If you look up here in the definition, what is nice about this is that actually the first node we're gonna tell the second node to print, and the second node will tell the third node to print, and so on. You can see this is recursive because we are calling print within print, even we have this object-oriented syntax here. Okay, if we going ahead and run it now, you could see the results. We have 7, 5, 11 and 4, all in separate lines. So let's go back here and change this method from writeLine to write. If I run it at this point, we can see that we have now 7, 5, 11 and 4 all in the same line. If we go back here to main, we select all, we can see that this is not scalable. Imagine if this list has hundreds or thousands of nodes. We have to do a different approach. So let's come back here to node real quick, and we put a new method that we will call public void add to end. That's gonna take some data. Well, a node can be in two different situations. Its next node can either be null or it could point to a valid node. So what we are going to do is check for that. If next equal to null, we know that we are at the end of the list. So we can just add that new node right here. Next equal new node and just pass the data. Else if next is not null, then we know that it's a valid node. So I can say next dot add to end, and we pass here the data. And again, you can see that this is a recursive code because we are calling add to end within the same method and telling that node that it has the responsibility to add the data. At this point, it's gonna pass this responsibility down the chain until one of these nodes will be null. Now we can come back here to main and we can clean up this nonsense. And now we can do is just tell this node to add a new node. So I said my node dot add to end a 5, my node add to end an 11, my node dot add to end a 4. Finally, what we will do is say my node dot print, and we'll see what the input is. Cool, since that is working. But typically we will not do something like this. We like to have a list class. So what we're gonna do is gonna shrink this down for a moment and drop down program a little bit. We're gonna need to create another public class mylist, and inside of this we're gonna create a node, public node head of list, or better we can call it head node. We also need a constructor, public mylist, and on the inside of this constructor, set the head node equal to null. One of the first methods that we want to create will be public void add to end. Just like we had in our node. We're gonna take in some data. At this point, head node can be in one of the two different states. I'm sure that you know already which ones are. It can be null or it can be not null. But if it is null, if it is pretty easy, if the head node is equal to null, we can just add the data right there. Head node equal new node and pass in the data. The nice thing about this is that I can just put an else here. If the head node is not null, then, and because of that, so I can say something like head node dot add to end in the data. So what's happening there is that the head node is gonna pass that responsibility down the chain, just like we saw before. Another method that we want inside our list is the ability to visualize it somehow. So we're gonna come down here, public void print, and again, because we already done most of the work inside of node, we can just say if head node not equal node, meaning that it's a valid node, then tell the head node to print. Great. Let's go down back here to main. So I don't need to work with this node anymore. Instead, I'm going to create a mylist that is called list equal new list. Well, at this point, I can start to add the nodes. List add to end, I pass it a 9 here. Well, in fact, what I will do is just copy this 9, then maybe a 5, 7, 11. Finally, after that, I can just say list.print and we'll see what happened. Great, seems like we have the same output, so things are working. So if you remember from the previous tutorial, so you remember how we talked about adding at the beginning and adding to the end and adding to in the middle. So let's create the methods, add to the beginning. So we go here, and after this add to end method, we can say public void add to beginning. Again, we're taking some data. So again, the head node can be in two different situations. It can be null or it can be not null. So let's do the easier one first. If the head node equals to null, then we can say head node equal new node, passing the data. If it is not null, we have to create the temporary node as we saw before, and we have to readjust the pointer. Just put an L. Then we go ahead and create a temporary node temps with a new node, passing the data. Right here, be careful with our pointer. Temp.next equal head node. Okay, then you can go back and look at the previous tutorial, visualize what is going on. Finally, you're gonna say head node equal temp. Now head node is pointing to temp. So let's test it out. Go back here to main. So I'm gonna take this list, copy and paste it. Let's comment this guys out, and instead of add to end, I will say add to beginning. Now at this point, we're gonna expect to see a different output. So when I run it, we will have a reverse order from the last one that we had. Now we have 11, 7, 5, and 9. And 9 was the first one that was added. So because we are adding to the beginning, it's gonna be the last node in the list. Okay, so let's stop this. So now that we created the two easy ways to add, so let's work in the add sorted method. What we actually gonna to do is we're gonna jump up here to the class node. So let's stop right here. Let's put public void and sorted, taking in the data. Now realize that we have three different states that we have to worry about. The first one is that the first node can be null. That's fairly straightforward. Then the second one is that the data is less than the next data. At that point, we know that we can go ahead and add it. Otherwise, we're gonna pass that responsibility to the next node because we know that the data is greater than the next node. So let's code this up. If next equals to null, then we go ahead and say just next equal new node and pass in the data. Otherwise, we have to worry if this node is less than the next node data. So we say else if data is less than next dot data. And then we can say node temp equals new node, passing in the data. Then we want to say temp.next equal this.next. And finally I'm gonna say this.next equals temp. Again, if this is confusing code to you, I recommend you to see my previous tutorial. Okay, if it is not this situation, what we can do is just pass this responsibility to the new next node in the list together with the data. Okay, let's drop down to my list and we can add this method, add sorted, and has parameter data. Because we are in this class mylist, you know that I have to work with the head node. And again, head node can be null in this situation. We saw before, head node is equal to null, meaning that this list is empty. We can say that head node is equal to a new node and passing the data. Otherwise, we have this situation where the data is less than the head node. Okay, let's check for that. We can say else if data is less than head node data. Let's think about it. If the data that we want to add is less than the node data, then we have to just add to the beginning of the list. Well, I have already written this method down here. Let's just call it add to, passing in the data. Well, if not one of these two situations, what will be? We will know that we will have to go further down the list. So we say head node dot add sorted and we pass the data. Great, let's test this out. We'll go down here, we comment out this code. I do a quick copy of this, paste it right here and comment. What I do is gonna change all this to add sorted. Okay, once I finish replacing to add sorted, I'm gonna run it. I'm gonna see that the data is sorted. I should see a 5, a 7, a 9, and an 11. So let's see what happens. Well, looks like it works. So that's it for this coding tutorial. I would recommend that you come up to the my list and play around with this code a little bit. Maybe add a remove method. Hopefully you understand a little bit more about linked list and how to implement it.